answers and then I'll see what questions that you have.
On the bonus. I go all the way to the end and then I divide it by the wrong side. I don't remember.
I'll just give some samples of 1 through 4 because it's worth talking about. And many times they'll have you do something open-ended like this because it's more like you could draw it incorrectly than there's a bunch you could draw correctly. I thought the 1 through 4 was a great way to start. Miss Stevenson probably wrote this worksheet, by the way. One day I'll show you pictures of the lovely Miss Stevenson. But you'll hear her name a lot. I've joked for the past like 10 or 15 years that you feel like that she's also your teacher. She's like one of the gurus of the AP calculus world. She's very well respected, extremely humble, but extremely confident. She's one that has given a whole lot of us, along with another woman named Birch Cornelius, that gives us a lot of information because they've got their hands on, they're like work for the College Board and they teach high school. So anyway, she gives a lot of good AP questions that she's either written or that she wrote or that someone that her friend, her cohorts wrote that really were on AP exams. And so you'll see, when you see these worksheets, I did not write these, you'll get familiar with them, and that's usually Miss Stevenson. So she thought ahead and asking her students years ago, if F has a limit but is not continuous at 3. Does anybody want to come up and draw one? F has a limit at x equals 3 but is not continuous at 3. Okay? You might want to pick a different color.
Do you like what?
That's yellow.
Anna, you're okay.
Eyes are
yellow.
I know those eyes are yellow.
It's hard to pick.
It is. It really is.
Ooh, pretty color, Anna.
Thank you. I came up with it myself.
No, I told you that she's
Hi, Morgan. We're doing the
Cancel.
The video's on, so y'all can fly. No fighting.
Right. Are we doing number 1?
Yeah, Anna.
Thank you. Awesome. Okay, notice she labeled her graphs. It's not necessary since there's nothing else on there for her to go 1, 2, 3. She can count by 3s if she wants to. Alright, so that's one that has a limit at 3, but it's not continuous at 3. Some of you may have even drawn one without the little dot. If you had me for, in fact, a lot of you did, but some of you didn't have me for algebra 2. But I may have done it in here where like I poked a hole in my shirt. Yeah, so it's sort of like if I had a pen, I'd gladly poke a bunch of holes in this. Okay, because they're infinitely small and it wouldn't hurt anything. But if I poked a hole in it and a little piece of like pink fuzz fell to the ground, I'm not going to try to find it and put it back in first of all because it doesn't really matter to the whole wear of the vest. Okay, so this may be just some free floating anomaly and it's not what you really want to study if you're looking at trend analysis. Okay. All right, so that's really good. And I think it also answers another question. Number 3, F has removable discontinuity at x equals c, for which f of c is, I'm sorry, 4. 4. This answers 1 and 4. If you didn't have the dot on 1, it wasn't necessary, but it is necessary on 4. It has a removable discontinuity at x equals c, for which f of c is defined. And so there is, so let's talk about continuity, what this has to do with continuity. So my question is this continuous at x equals 3? Is f of 3 defined?
Yes.
In this case, f of 3 is defined. One of my favorite things is if it's not even defined there, game over. I don't have to worry about continuity, and lots of times that means I also don't even have to mess around with the next question, because I can go, it's not continuous. I'm not talking about it, okay? So it's very similar to all my silly, examples that I give. Not sorry, but if I was walking, to check uniforms during the fire drill, and I didn't realize that there was just a girl passing by that didn't go to Marymount, and I write her up, okay? I mean, it's just kind of game over. Like, she didn't go to Marymount. I can't even write her up. I can't even find her in the course management system. Do you see what I mean? So it's just an anomaly, okay? But f of 3 is defined. Is there a limit of f of x as x approaches 3?
Yes.
Yes.
All right, so f of 3 is defined. The limit does exist. But why is this discontinuous? What would you say? Hopefully you would say the limit of f of x as x approaches 3 does not equal f of 3. In fact, you could go straight to that and it says it all in one fell swoop. Or you could build up to it, okay? I'm sorry, that's one Harry Styles crazy. Can't be jacket, but I'm gonna keep going. There was another thing I was gonna say about this, I can't remember. Oh, please don't say words like they don't meet or it doesn't fill in the hole. This says it, okay, in good language. The other two, let's see. Oh, so number 2, f is not continuous at 3, but if its value at 3 is changed from f of 3 equals 1 to f of 3 equals 0, it becomes continuous at 3. All right, does anybody want to do that one? Number 2? Okay, Emma's going to do number 2.
So if you moved it from
Yeah.
0, 1 to 0, it would be continuous? Okay, yeah. Thank you.
He has great hair, doesn't he?
Yeah, he does.
His eyes are so beautiful. Look at his eyes. They're like
Also, that's empty. It doesn't look.
That's kind of so that's an open circle at 3. And if we had this dot, and if we brought it down and changed it to that, it would be continuous. Okay. So I think are y'all okay? 1 through 4.
Yes.
Number 5. This is what I wrote. F of 1 is not defined. What were we asked? Use the definition of continuity to prove that the function is discontinuous at the given value of a, and then sketch the graph. That would have had a hole in it. It would have looked like a line if you drew it correctly. Huh? I'm sorry, Anna, what? Factor and cancel, you can see the hole. But your answer for why it is discontinuous is it doesn't meet the first criteria. F of 1 is not defined. Game over. All right. Number 6 going across. This one, let's do 6. Gosh, this is so aggravating. Okay, I don't know whether to continue or not. Okay, so another thing I was writing on people's papers, not counting off, but I would later because the language was not quite correct. You don't, if you have g of x equals or f of x equals, you don't need like a y equals or any more equals in here. Like you're saying y equals these things, okay? So y, what I'm going to go and factor out an x up here, x times x minus 3 over x plus 3, x minus 3. And this is true if x doesn't equal 3, and all the rest of the world is going to do this. They're going to be at 1. If you factor and cancel like Anna suggested here, and then if I fill 3 into the top, I get 3 over 6. And so if I have the limit of f of x, sorry, I don't want to start there. First of all, is f of 3 defined?
Yes.
So I got to keep going. Number 2, is there a limit of f of x as x gets closer to 3?
Yes.
There is. What is it?
1/2.
So the limit exists. Okay, because our graph is going to look like this. All right, so at 3, you have 1. Since I'm in Harry Styles hair, I need to make that yellow. Okay, so then when it's not equal to 3, it behaves like this. It would have a vertical asymptote. I have never drawn this one, so I'm kind of making it up as I go. 0, 0. I think it goes like this.
Yeah.
Kind of something like that. It's got a vertical a horizontal asymptote of 1. Can y'all see that with the x over x? Okay, so it looks like sort of like that, y'all say. Alright, so the limit does exist and it's 1/2, but number 3, f of 3 does not equal the limit of f of x as x approaches 3. Those have to be the same. Those are the language we use to say it meets. Hopefully that makes sense. Or that the hole is filled in or whatever. Okay, number 7. The limit as x approaches 0 does not exist. Okay, so there is an f of 0. F of 0 is defined. This falls apart though when I get to the limit part. The limit from the left was 1 and the limit from the right was 0. So the limit did not exist at the point in question. Are y'all okay with that? Alright, number 8 was k was 4/3. Going across number 9, k was 2/3 and m was 9. I don't think it was, never mind.
Wait,
Yeah.
what's
Never
Okay,
mind.
what's 2/3 and what's
M was 5/3.
Yeah.
So on number 9, k was 2/3, m was 5/3. Number 10, k was 4, and number 11 is where m is 9. Number 11, m is 9, and that was all you had to do for homework. We'll do some more of the worksheets, so leave it out. Okay, questions on 8, 9, 10, 11. All right, Grace?
No, I was really confused on 9.
9. All right, this is number 9.
The one with K and F.
If you have 2 variables defined, strongly expect, everybody suspect that you're going to have what's called a system of equations. You're going to need more than one equation to get rid of one of the variables. Extend page doesn't work like it used to. Okay, so anyway. Alright, so we have x squared plus 5. If x is greater than 2, between -1 and 2, we have m times x plus 3 plus k. And x is less than or equal to -1. And I have 2x cubed plus x plus 7. And g of x equals that. Alright, let me pause and say something. All of a sudden you got to this one. One thing bothered me about this one, I even started working it kind of incorrectly, because I'm used to it going like, Caitlin and I talked about least to greatest.
Yeah.
And I was matching up 2 and -1 just out of habit, because usually it goes least to greatest, those match and then these match. Like it goes, anyway, some of you know what I mean. Kind of unusual for it to go from that direction. So you might even could rewrite it if it makes you feel better, but honestly, you was starting this wrong. It wasn't making any sense. So I'm going to be less than -1, then between on my number line, and then greater than. Okay. There was some. This I've told you before. As we close this door and we talk in here, that this is not. I mean, AP Talk speaks is hard. Okay, but it's not that. It's more of a willingness to endure and to try, which is going to set you apart in any job and any endeavor that you take, actually. So my point is, like, if you've got to clean up your room and all that's happened in the last week, it's gotten messier and messier, you don't want to go in there and do it. But once you pick up that first sweater and that first skirt, you feel a little bit better, most likely. It's all of a sudden you've started on it anyway, and you go, I'm just going to go ahead and finish, or I'm going to get a lot done. I got to write 1 billion trillion recs this year, and they're hanging over my head like your research papers or something that you have to do. But I'm going to feel a whole lot better once I do the first one, right? I'll have gotten them kind of in my rhythm, and I can start cranking them out, because I used to do tons more with classes of up to 500 in my other schools. So I don't know how many I used to do. I refuse to count them because I don't want to know. But y'all see what I mean? There's something that hangs over your head, and you're just like, I don't want to do it. But once you get started, it feels a lot better. Okay, so jump in. All right. I don't know where my extend page went, so I'm going to erase up here. So I'll be working it up here. All right. I will never ask you on a test or even homework, really, but after a test and a quiz, something that I haven't shown you how to do, or that I thoroughly believe you know how to do with what I have shown you, okay? I can't show you everything that's going to come up on the AP exam, nor would I, okay? That's just sort of life experience. But we know what we're doing here. Let's start at -1 and just get started on it. as I move from left to right. If I fill in -1, I get 2 times -1 cubed plus -1 plus 7. And I want that to equal this one as it transfers from one piece to the other. So I want it to equal m. That's not good. If I fill in -1, I get 2 plus k. And then we all kind of freeze up. I've frozen up before on this. Does that give me 4?
Yeah.
4 equals 2m plus k. Don't pause too long and sit there and fret over it. Keep on moving. You just got 2 variables. That means there's probably going to be some m's and k's in the next one. And you can get rid of one. Keep moving, okay? So, now I'm going to see what happens as it transfers from this piece to this piece. I was going to say I don't know what this looks like, but I've drawn it before. But my point is, you can have all of these piecewise functions going from one to the other. And it could look like this, and then this piece, and then that piece. They don't have to meet. You want to make this graph continuous. You want to leave one piece and pick up the other one when you get there. Okay? Hang on, Grace. So now I'm going to fill in 2. If I fill 2 into this, I get m times 2 plus 3, 5 plus k. And then I've found the value here. Now I want to find the value here, which is 9. So now I have 5m plus k equals 9. And then it's just up to you. You can do elimination or substitution. I'm a bit bigger fan of elimination than I am substitution when I can use it. I get a little less confused if I can just subtract those and the k's will cancel out. I'll find m, then I can go back and find k. Grace?
So in the top equation there, so for the m, like 2m plus k, so did you get that from the equation m times k plus
I fill -1 into this, and then when I fill -1 into this,
Okay.
they have to equal each other.
I was just
I want to make
confused,
those. I want to make those limit from the left equal the limit from the right. Okay. All right. Anything else on so far? Okay. So now let's talk about the intermediate value theorem. Okay. So let's say so new topic. You can refer to it as the IVT. There's some things that I'll say like crummy slope, which is just the good old, not the good old, the crummy geometry slope from point A to point B. So I'm doing f of x minus fa over x minus a without a limit symbol in front of it. That's just crummy slope. Sorry, intermediate value theorem. Okay. Some things I say you can't use, but like DNE, IVT, it's intermediate value theorem. It seems extremely intuitive, but it's very, very important. People can find things out a lot from the intermediate value theorem, even in research. This is sort of how it works. First of all, let me give you some example. Well, hang on. What if I told you f, what if I'm looking for a 0, okay, of a graph? And I see that f of 3 is -5 by filling in or looking at a picture, mostly filling in. And then if I put in 5 and I get 7, what do I conclude?
The 0 is in the range of values from x equals 3 to...
Yeah, good, I'm glad you saw that. So if I go from negatives to positive, I have to cross through 0. And not only do I have to cross through 0, it has to be during that time frame, which can be very valuable in different research and other scenarios. Like, sometimes you don't want to know that it happened, you want to know when did this happen, or that you can guarantee someone that it will happen during this time frame, okay? So, do y'all see what, now could it be 0 other times?
Yeah.
For all we know, could it be 0 more than once during that time?
Yeah.
Okay? Well, what about this? There you go. Okay? So I'm not guaranteed that. Of course, I planted that one in front of you because I know what we're all trying to do and I don't want to go there later. Do you see how all of a sudden continuity is extremely important? there's probably an infinite number of graphs that I could draw where that doesn't happen. We've seen graphs like this. You know, kind of like on your last test that don't have the vertical asymptote in them or whatever, okay? So, for instance, now let's talk, are y'all okay with that? So all of a sudden you told me what I want to teach you. You can't say that if it's not continuous. If it is continuous, it is impossible for me to get from here to here without going through zero, right? At least once. And I love how she said it because it's about this and this. It happens here during this time is all I'm worried about, all right? You're gonna like working the problems once you get the theorem down. I need to shrink.
Yes.
Shrink Harry, so he's got
Oh my
it.
god, I love that.
Let's see.
Haha. Oh no, he got smashed. He's like this.
I'm trying to fix him. Let's see.
You don't have to fix it. Oh,
Make him really tall and skinny. I mean,
yeah. Perfect.
There.
yes.
There we go. Okay, so anyway, let me give you some real life examples. So suppose this morning when I walked to school, it was 62 degrees at 7:30. And then let's say that I leave school, for me sometimes it's like 7 or 8 o'clock at night. But suppose I leave today at 3:30 and actually really make it to the volleyball game. And I check my app to see if I need like my little jacket or whatever, and it's 80 degrees, okay?
Yeah, but the soccer's so warm today.
Today and the weekend's gonna be. Okay, so anyway, can I conclude that at some time during the day it was 77 degrees?
Yes.
Because temperature is continuous. I think it's totally impossible on a thermometer, I don't think, I know. I can't go from 62 degrees to 80 degrees and go that I didn't do that, okay? What's very interesting, if you can think about it, get outside of research, it can be parental or teacher, you know, where somebody saw you somewhere and you're like, I didn't do it, I wasn't there, but you saw them at this floor, you saw them at this floor, there's no way you can get from the 6th floor to the 2nd floor and not having been on the 4th floor when you maybe weren't supposed to go there or something. Do you see what I mean? So I'm sure, I don't know. You always hear stories of parents catching people. I got lots of stories, but today I don't want to get off the beaten path, so let's go back here. So y'all agree with that? All right, now, could it have been 83 degrees?
Yeah.
Could have been, but I have no
Yeah.
proof
No.
of that, right? It could have gone up and then in the afternoon, you know, start going back down. Some rain could have come through. I don't have any way of knowing that. So it's what Anna said, that it's gonna be 77 degrees, could be more than once, between 7:30 and 3:30 is what I'm looking at. Was it ever could it have been 77 degrees at 5 o'clock in the afternoon?
Yeah, maybe.
Could be, I just don't know. So it's all about what's happening here and here, okay? All right, what about this? What if I get the test back and there's a 62, which there was none, and there was 77, and so can you conclude, oh, well, somebody made a 75?
No.
Because grades are not what? Continuous. But you see how you continuous? Continuous. Okay? So you see we've got to know continuity. Is the graph fluidly moving through or is it not? Alright, so that's all the intermediate value theorem is. If I look it up, I left a book down here so you have one.
How would you like for the start? I don't think we've gone to that part. It's like 60 years ago, then you explore it, and it's like the next value is, you know, that at the other, at the Y, because you can change this 5 to 6, it has to be.
Okay. So our book and any book, I'm sorry, just about continuity, it's got the little one. That's not what I meant to look at. I need to get that in here. Oh, let me pause here while I'm stripping through. things you're allowed, functions you're allowed to step out there and say it's continuous, there's tons of them. You really don't have to prove continuity much in here, you just have to check it, okay? Because you might be worried about trying to prove a function is continuous. If I have 1 over x minus 3, and they give me a window, if they give me a window of time of 7 to 8, I'm okay to go in and work on that. Y'all see what I mean? Because it's continuous during that time frame. Things that you were allowed to step out and say are continuous are polynomials that are not rational functions. I mean true polynomials like 7x cubed minus 5x squared, no negative exponents or anything that could cause a denominator. You can say this is a polynomial, it is continuous. Are y'all okay with that? What trig functions are continuous? That's it, right? Only sine and cosine? But you can say sine is continuous, therefore. We hear groans every year that we're grading AP exams in June where they tell us that we can't give the points on like the A, B, or C part if the student has not announced this is continuous. And so I'll get you used to that, okay? To where, because they just launch into whatever they're working on. And it did apply, but without them saying, I checked for continuity, they really shouldn't be talking about it. They shouldn't be, running around lighting people up for what they're wearing if they don't want to wear them. So I need to check that first, okay? So,
So you have to write something, like you have to write.
f of x is continuous, so therefore I'll do this. And I don't ever write numbers, so therefore, but I state continuous. You'll learn, you'll do it, I'll get you used to it, I won't that hard. Okay, girls, I'm gonna read the intermediate value theorem, and it's like, technical jargon in the textbook, okay? If f is continuous on the closed interval, that's real important. It has to be continuous on the closed interval. You don't know yet how important that is, but there's some things that there's some theorems that we found physically and mathematically are okay to work on if they're continuous on an open interval. This has to be continuous on the closed interval. I don't really know if that's true. F of A does not equal F of B. It's any number between A and B. Oh yeah, that does have to be true. So let's talk about that. F of A does not equal to F of B. I can't use the intermediate value theorem if F of A is 7 and F of B is 7. It doesn't, y'all see, there has to be a difference to start talking about there's a number between. I mean, that's common sense. I don't know why I stumbled over that. Maybe it was just so easy it was hard. Because I usually don't even address that issue, but we're talking about intermediate, we're talking about betweenness. The between value, between numbers. By the word value always means y, unless they say what's the x value. If I say what's the value of x equals 3, I'm asking for only a line. I'll reiterate a lot of that. It says, and k is any number between f of A and f of B. Then there's at least one number c that is between what? A and B. Now we're talking about our x's. There's at least one number c that is in the, I'll explain that in a minute, such that f of c equals k. Do you see why I gave you, watch this girls before I go on. It could actually happen at one of the endpoints. You might wonder how that could be, but there's at least one number c, I'm sorry, yeah, I did that wrong. There's at least one number c in the closed interval from A to B. Right, that's what Anna intuitively looked at. It's just that maybe you can see now why I gave you some examples before I do the theorem. What it's saying is that if it's continuous, this is the biggest thing. If it's continuous and you have endpoint values that are different, that to get from one to the other, you have to go through some y value that's between those two y values. And not only that, we know that it will happen between the two x values. It could happen outside that, but we're not looking for it. Are you okay with that notation? If you want to write yourself a note, it's in your book on page 77 if you want to look at it. You don't ever have to reproduce theorems for me, but I'll work them in there like already. I feel like you've got continuity down really good. Okay, so I'll work the theorems for you. So now let's look at your worksheet. And let's do number 12. So this is number 12. So just fill in as we go, number 12. All right, so you have f of x is equal to 2 plus x minus x squared. We've got the interval from 0 to 3. All right, show whether the conditions of the intermediate value theorem hold for the given value of k. If the condition holds, find a number c such that f of c equals k. If the theorem does not hold, give the reason and sketch it whether or not it does. I'll do all that, okay? First of all, I would say f of x is continuous. And I will recommend that you be kind of sneaky, because if now after my speech of needing to state if you're going to use a theorem that demands continuity, say you're not quite sure, I'd go f of x continuous and keep on. Please write it down if you think it might be. If you know it's not, don't write that down. But I mean, this is a polynomial, so you see how I can go forever? Is it can be undefined anywhere, am I in any trouble whatsoever? Okay? So you can jump out there and say f of x is continuous, but you better say that or you won't make the points, okay? Then you just start into it. So I found f of 0, and I got 2. And then I found f of 3, and I got negative 4. And so their question is there an f of c that ever equals what? 1. K is giving me right now my y value. So hopefully me writing them down like that makes sense to you. Okay? Now, should I go ahead with the mean value theorem? It meets the criteria in that the number 1 is between 2 and negative 4. Now, what if they said, is there a number where f of c equals 5? Probably, but I don't have any reason to know that from my information. Are y'all with me there? Okay. So it meets the criteria in that k is between my y values. I'm looking for x that would land between my x values. So now here I go. So now I'm going to say 2 plus c minus c squared. Does it ever equal what? 1. Okay, so that gives me 1 plus c minus c squared equals 0. And then I'm going to factor. And that gives me, oh, I can't factor that.
Yeah, you can just kind of tell.
You got to prove it. You got to find the c. That's your whole point. Okay, so if I launch myself into the quadratic formula, everybody get out your calculators real quick. If I launch myself into the quadratic formula, I think we all know that I'm going to get something like, I mean, I actually know what I'm going to get, but I'm not going to call out what it is. Well, I'll call it out. You get 1 plus or minus the square root of 5 over 2. Okay? You're not going to know what those numbers are most likely. I mean, you could set it, I mean, do y'all see what I mean? That just doesn't do me any good. Plus, I don't care if this says 1 plus c minus c cubed. Does not matter to me as a calculus teacher. And the quadratic formula only does you good if you have a quadratic. But as a calculus teacher, I don't care if it's quadratic or not. I'm not a big fan of the quadratic formula. I just assume if you're going to have to use a quadratic formula, let me promise you're going to have your calculator anyway. So why not just do it the easy way? So let's do this. Pull up your calculator. I'm sorry, I'll pull up my calculator. You've got yours out. Let's put in 1 plus c minus c squared, of course using x, in your y equals. These skills are necessary. You can't, I don't really want to learn this. I'll just do it. These skills are necessary. It's also necessary that you learn how to transfer your technical skills on paper in calculus terminology, and I'll model all of that for you. Go ahead and graph it. In fact, I could just graph this between 0 and 3 is all you're concerned about. Do you see a 0 between 0 and 3? I think you'll see 2 zeros, won't you? Because it's an upside down parabola. Okay, so let me catch up. So I have C, what do I have? 1 minus x squared, or was it plus?
Minus.
All of that's minus?
No, one of the first is plus.
Alright, I'll just look at our standard viewing window for now. I could zoom in if I needed to, or change my window if I needed to. I definitely see a 0 between 0 and 3. Notice there's another one out there, but it is not the answer to this question. So leave it alone. So I'm going to go to second calc 0. You want to be to the left of it, but you want to be kind of over that hump. So I'm going to move to the right. Just somewhere over the hump. It's a cuter little flower than it used to be. I'm going to hit enter. Then move over to the right. Past the 0. Hit enter. Then enter. And so now you get 3 decimal places, 1.618. Okay, do you see what I mean about, I don't care if it's quadratic. In fact, those numbers don't really mean that much to me anyway, okay? So the answer here is 1.618. So this occurs when, I would write this, when x is equal to 1.168, f of x equals 1. All right, let's move on. All right, number 13. Oh, I did graph that one. I did it on the calculator. Number 13. I think you're familiar with thinking about this one. This is that little semicircle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So our domain is negative 4.5 to 3. And they really only want me graphing it on that domain. So negative 4.5 to 3. All right, first of all, is this continuous from negative 4.5 to 3? Yes. Where would this be discontinuous? When x is greater than 5 or less than negative 5. If they put me like from negative 4.5 to 7, I would say, I'm not doing this problem, okay? I will say it is continuous. The function is continuous on this domain. All right, so then you just find f of negative 4.5 and find f of 3. All right, so you just fill it in. I filled it in and didn't write down what I got. Will somebody fill that in for me if you haven't already? 25 minus negative 4.5 squared.
2.17. Oh,
And then square root
is
is
2.17.
Thanks, Carla. So 2.179. Good. Always give me 3 decimal places, unless you're told otherwise, which is sometimes happens. F of 3 was 4?
Yeah.
Was it 4?
Yeah.
All right, and your question is, does it ever equal 3? Is there an f of c to where it would ever equal 3? According to the intermediate values there, and there should be, right? Because 3 is in between these, so there must be a number between these. I can't get from here to here without going through 3. So f of x equals 3 looks like this. We were at 2.179, and then we were at 4. And you see it does equal 3 sometime during that time. And in fact, my picture is pretty good for me. I'm shocked that this is going to work out okay. All right, now, so you can do this. You just go back to your function, and you'll say the square root of 25 minus c squared. I'm going to force it to be what number? 3. Then I'm going to square both sides, and I get 25 minus c squared equals 3. 9, so that was right, thanks. So then I get c squared is equal to 16. Back on that horrid stuff we talked about, I get plus or minus 4, but which one do I grab? Minus 4, because positive 4 is not, and we're not worried about that. They don't go here, okay? And so my answer would be when x is equal to negative 4. Notice that I use X's and C's interchangeably. In fact, nobody would count off if you never even used the C. You could just do that with an X in it and announce your answer. Can y'all see that by my crummy graph is not so bad? It looks like that's where it hits 3. Okay? All right, let's go to 14. All right, 14, we have f of x is equal to 1 over x minus 2. And if they said go from 3 to 5, it is continuous on that domain, right? If they said go from negative 3 to 3, I would go not continuous, game over. Okay, don't really write game over. But most readers are really funny, and we would laugh about that. We would read it out loud to the table. The tables are set up sort of like this. We go leaders up there and the graders right here. So we laugh about a lot of things. Okay, so anyway. So now I'm going to find f of 3. So you just write all this down. You say it's continuous. F of 3 is 1. F of 5 is 1/3. And we want to say that it equals a 5/6. Is there an f of c that ever gives me k? Isn't 5 over 6 between 1 and 1/3, which is 2/6? So there has to be some. You show them all of this, though, that you know there has to be something between those numbers. So then I'm just going to keep the x in it this time since I said you could. You force the issue, and you know ahead of time you're going to get an x because it's continuous. What's interesting is it may or may not happen if they give us an incorrect domain, but we don't have to fool with it. So it gives me 5x minus 10 equals 6, 5x equals 16, and so it should occur when x is 16/5. That's when it happens, when x is 16/5, which is 3 1/5, so it is in this domain. I'm not going to graph it, I'm going to move on. All right, second page, you'll be doing, part of your homework will be to do 15 through 19. X out 20 and 21, not a big fan of those questions. They're probably great questions, I just want you to do something more important. So I'll post all of this online for you, but let's just put this aside for now. Okay, next, I'm going to throw some trig limits up here. You'll notice some, there's some more hairy stuff. You'll notice some adjustments to the syllabus that we got a lot done today, but I won't get as far as I'm super duper hope. So I'll adjust the syllabus, but you don't have to care, you just go to assignments, okay? So what if I'm taking the limit of the sine of 5x over 2x as x approaches 0? So what is your first rule of limits?
Plug in the number.
Please don't go doing fancy tricks like conjugates and factoring if you have it in your chest. Suppose that Alana and I plugged in the number and we got 1/4. We need to think for a minute, like is it okay from the left to the right? But chances are that's the limit. So plug it in, don't go do fancy tricks, okay? If there's one on the test like that. Here too on the test like that. The x over cosine x was fine. Cosine of 0 was 1 and everything was okay. We didn't have to do anything weird to it. Alright, but do we get 0 over 0? Yes. By the way, don't fall for cosine x. Cosine 0 is 1. Okay, but in this case, I gotta keep looking. I had to write this on a few people's tests. If you get 0 over 0, yes, that's undefined, but it doesn't mean there's not a limit there, okay? Because of that infinitely small hole that might be there most likely. So now we don't, a couple of rules in here can tell us that we don't want to launch in the L'Hopital's rule right this minute. One day I will teach it to you, and it will be easier. Notice the 2 girls that laughed. But it was very impressive work. I mean, so impressive. Anyway, we'd rather do it an easier way, all right? So what I'd like to do, does anybody even really know what I wish this said?
Sine 5x over sine x.
Very good, thank you. You said that, Carla? Okay, so at least I got that pointed across where she learned it somewhere, okay? I wanted to say sine of blah over blah. Blah is not a real math term, but I use it a lot just to take it out of math window for a minute. It's got to say sine of elephant over elephant, okay? So you're gonna have to be an engineer. You saw me do this on the video, some of this, okay? That 2 is kind of in my way, but I can't lose it. So do you see I'm just gonna kind of scoot it out a little bit? And Carla and I are gonna introduce a 5, but that's not fair unless I introduce a balancing 5. Do y'all see that? Okay, now, what is this gonna equal? Sine of u over u as x approaches 0. That was 1. And what's the limit of a constant? So I just have 5 over 2 for my answer. Yeah, I see it up there. Please don't assume too much. Okay? I just work the problem out. I've seen people, I don't want to stop you from making assumptions because that's what really good mathematicians and physicists and research people do. But we better check our assumptions also because we can get in a lot of trouble with them. So we do want to make sure that it always works, and that won't always work. So just work the problem. Okay, so now I'm going to, I don't think you have this worksheet in your hand, so I'm just going to write another one up here. The limit of the sine of 3x over 3x squared plus 12x. Yes.
Sorry, I know we in class like 5 minutes we make she's not there.
Yeah. So, it sounds like you understand this, but you can watch the last 5 minutes if you need to.
Oh no, I'll be back. Eventually, like not.
Should I be on 5 minutes, I guess.
Sorry. Sorry.
So anyway, please don't do anything to it. Maybe at first, maybe you don't need to do any algebra to it. It may just have an answer. That's very likely, but this is 0 over 0, which means keep looking. You're not guaranteed a limit, but you're guaranteed you need to look for it in case there is. You can still have 0 over 0 and come up with D and E. Case in point on your test, the absolute value of x minus 4 over x minus 4 was 0 over 0, but there was no limit. Do you remember that one that went to 1 and -1? But you've got to look, okay? So I wish that said sine 3x over what? 3x. All right, so, and there's these wonderfully permissive limits that just let me do like all the things that I wish I could do to other functions. What I mean by that is I usually won't let you take the limit of something and the limit of something and stick it together. Like sine of A times B, girls, is not the sine of A times the sine of B. Logarithm of AB is not logarithm of A times logarithm of B. So it's a really big deal that limits let me go, I'm gonna take the limit of this and the limit of this and multiply it together. It's a pleasure. It's a treat that you don't get very often, okay? So anyway, this one, do you see goes to 1?
Yeah.
And so that's kind of gone, that turned into 1, and so I have left 1/4 as my answer. Once that's gone, it's sort of like you're not really canceling out. You know how when you other holes, you cancel out and then you fill to the leftover. You know that goes to 1 and you fill into the leftover.
Does it only work if like sine is on top?
No, it can be on the bottom and you still do the same thing. It can flip and be 1 either way. The cosine one's kind of tricky. I don't have one here in front of me. Okay, so let's do at least one more.
Wait, can I take a picture of Carrie real quick?
Yeah.
You have these
You
pictures?
said those two.
That's a good one.
She likes it with the
People
map,
like
maybe.
to take it with them out. I posted one on my Instagram feed the other day of the friends.
On your Instagram?
Oh, of your friend's dog.
Yes, they were so excited. They reposted it on their
She
Instagram.
said
Because it looks so cool with the puppy. All right, so you have the limit of sine x plus sine 4x over 5x. I'm going to go ahead and do this because we're in a hurry and I'm going to need to later. Over 5x, common denominator. Oh, I'm sorry, you didn't see how it looked originally. I forget you don't have this worksheet in your hands. Okay, so this is over 5x. I get 0 over 0. Now I've got to go into all these techniques, which again makes you an engineer, okay? You've got to pick up your tricks. There is not one set thing that I can tell you to do. You get sharper and sharper by struggling with your homework, okay? So I'm going to break this up into a common denominator of 5x and 5x. This front one, can I reduce it and just call that 7/5? All right, now on this one, Carla and I wish that this said 4x on the bottom, but it doesn't. So I'm going to tell the file to move out of my way. And I want everybody in here to notice how, did you see I keep writing the word limit until I'm finished? Okay, you should too. I'm gonna put a 5 here, how will I balance, I'm not gonna put a 5 there, what am I gonna put there?
4.
And how am I gonna balance that? Y'all got it, okay. And this goes to 1, so I have 7/5 plus 4/5 is 11/5. I love how the algebra will be merged with what you would find if you investigated it on your calculator. You will have a quiz on trig limits along with some written work to do for the next class. Not a whole lot of written work so that you can study how to do the trig limits. Please pack up, but let me tell you this. I'll say optional, here's some problems, trig limits with answers. Please read assignments carefully because I might say, I would not ask you number blah, 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 okay? Also, there's one other thing I was going to tell you. Oh, one day, you will learn a faster way to do this and even faster than this. Sort of like what you did. Bye, girls. I'll post homework in a few